Hey guys, hi. Welcome to one another amazing master session. How are all of you doing? Great? You guys are doing super good? Hi guys, hi. I can see a lot of my own students. That's superb, that's superb. Hi. Welcome to the session guys, welcome to the session. Great, amazing. The previous webinars were good, right? Okay, great. So let's make this webinar also completely superb and productive for all of you. Okay? So right now, for people who don't know me, my name is Abhishek. I'm an aerospace engineer. I'm also a master teacher for physics at Vedantu. I personally handle 9th and 10th standard students and train them for board examinations. Okay? And right now, more than 500 students are under me, being mentored by me. Okay, so right now I have taught and mentored like thousands of students, and I have more than 5+ years of experience in teaching physics. As I already told my my description that I'm an aerospace engineer. So basically I am into physics too much. Whatever happens in the atmosphere, in the space, or rockets or satellites, so all of them fall under my forte. So that's the basic reason that I'm in love with physics. Whatever happens in the natural phenomena, I'm into love into that. So I hope all of you guys also love physics. Yeah, you do, right? Exactly. That's it. See, physics is super. I know that. And also, I'm pretty sure that many of you guys will be scared about numericals, correct? And that's what we are going to deal with today. Yeah, I can see a lot of students saying that not that scared, sir, but somewhere in between I'm scared, and few of you guys are also pretty much scared about it. So today, I'm going to tell you guys 5 best practices. 5 best practices to solve physics numericals for grade 10. So that's the entire topic for today's webinar. So as you guys know that it's pretty difficult to take the entire chapter of the entire textbook to explain the numericals. So I thought, why not take one specific topic and clear that up. That would be really great, right? So that for throughout the entire year, even if you go in your 12th standard or when you're doing JEE mains, you don't forget these concepts which you're going to learn today. Okay? So we'll take a small part of one particular chapter called as light, reflections and refractions. Inside that we'll take the reflection concept. Inside that we'll take the concave mirror concept. So in general, mirror concepts, and we'll try to solve few numericals. Okay, in the best way possible. That's what we're going to do today. So yeah, and also I am an inventor of Rocket Pro. If you guys don't know what is that, it is the only online course, which actually gives you the experience, hands-on experience in making your own rockets and also aircrafts. And as you can see the motto here, learn it, build it and launch it. So students don't only understand the technical concepts of Rocket Pro or rockets or satellites or aircrafts, they also make their own models and then they launch it by themselves. You know how much satisfaction that is, that you have made something and launching by yourself. So I'm the inventor of that as well. So now coming directly onto the topic, let's see what and all we are going to do actually today. Okay, so before going on to that, I would like to share a very important quote with all of you, which I share it to all the students, and to keep them motivated. It's a very good quote. It's said by Mr. Henry Ford. I hope you guys know who's Henry Ford. Yeah, you know, right? Yeah, good, great job. So the quote goes like this: when everything seems to be going against you, remember that the airplane takes off against the wind, not with it. So right now you might be facing a lot of difficulty in your studies or in your academics or in your sports or whatever field in your life is, but don't worry, stick on with it, work hard, be dedicated, be motivated, and you will get it. You are going to achieve your goal. Great. So let's try to see what we are going to understand today. First of all, we will be revising the ray diagrams of mirrors. Now, specifically speaking, this particular session is going to help 2 kinds of students. Number 1, student who has actually already covered the light chapter and they are looking for a revision, and they are also looking for the best practices and face difficulty in their numericals, and this webinar is going to help them. Now number 2, those students who have not covered the light chapter, because many of the schools don't take light chapter first, they take electricity first. Correct. So those students who have never covered light chapter, this particular webinar, this particular master session is going to help them to actually solve the numericals in the most best possible way. Got my point? So today I'll not be going in deep into ray diagrams because for doing the numericals, that is the most basic concept which you need to know. Okay? But I will be revising them and I'll tell you the key points which you need to remember even if you don't remember the ray diagrams itself. I'll give you the key points. So make a note of that as soon as I give them. Okay? Make sure of that. Number 2, we'll be dealing with the sign convention in detail. Why sign convention in detail, not the ray diagrams? Because ray diagrams are much more simpler as compared to sign convention, because a lot of students actually lose marks in the sign convention. Okay? Many of you guys might not know what is sign convention, right? Many of you know, many of you not know. Great. So that's where we are going to put our most of our effort in. Then we'll start and go forward to solve some crazy numericals which are not only from 10th standard but also small surprises will be coming in your way. Okay? I'll tell you where are these questions coming from. So you will be really surprised when you solve them. And obviously, in the entire course of the webinar, you will be getting lots of tips and tricks and also lots of best practices to solve the numericals. So that's the introduction, the boring part. Let's get into the actual part of the webinar and let's try to learn something. All of you with me? Shall we go forward? All good? Crisp? Clear? Yes? Awesome. So let's start doing it, guys. So number 1, this is one of the questions which we are going to solve after 50 minutes. Exactly after 50 minutes today, this is one of the questions which we are going to solve. Not me, but you. Read the question right now and keep it in your mind. The question says, an object is placed at a distance of 40 centimeter. Okay, clear. From a concave mirror. Superb. Of focal length 15 centimeters. So till now it's super clear. You know, it's a crisp and clear question. The next statement says, if the object is displaced, through a distance of 20 centimeter towards the mirror, by how much distance is the image displaced? Now suddenly into the concept of optics or into the concept of reflection, motion came into the picture because now they are asking some sort of displacement. Correct. And now this is the part where a lot of students go confused. And also, this is one of the most important 12th standard question. Also, it has come somewhere else also, I tell you that. So this question you are going to solve exactly after 50 minutes. So be very careful. Okay? Look forward for it. So let's move on to the first concept which you need to know, as I already told you. Correct? So first thing, the best practice to solve any kind of a numerical in your light chapter must be number 1, to remember the ray diagrams. To remember or to convey the ray diagrams very, very clearly. Guys, take a note right now that ray diagrams are super important. If you consider in terms of light chapter, which comes over around 7 to 8 marks, at least 2 marks will be there for ray diagrams. Okay? Anything might come. There are in total 16 ray diagrams in your chapter. There are total 16 ray diagrams in your chapter, and out of that 16, 8 are there for mirrors, which comes under the concept of reflection, and 8 are there in the concept of lenses, which comes under the refraction part. Okay? And out of this 8 ray diagrams, 6 ray diagrams belong to concave mirrors for reflection, and 2 ray diagrams belong to convex mirrors for reflection. Similarly, for 8 ray diagrams in the lens part goes on for 6 go for convex lenses and 2 go for concave lenses. Okay? So let's forget the complete system of lenses today. Let's completely focus on the numericals of your mirror. Great. So guys, please kindly make a note right now that you need to know your ray diagrams to do this. Now, as I already said that many of you might not have learned the ray diagrams already. Many of you guys would have learned. People who remember, well and good. People who don't remember, that's okay. That's completely okay. People who don't know it, listen to it very carefully. These are few key points which you need to know even if you don't know the ray diagrams. Okay? So number 1, always remember that a concave mirror I hope all of you guys know what is a concave mirror. Correct? You guys know that, no? A concave mirror is a mirror which is curved inwards. This is a concave mirror which is curved inwards and the light ray falls on the inward part. So that is my concave mirror. The concave mirror is also called as a converging mirror. Please make a note of that right now. A concave mirror is also called as a converging mirror. Okay? Now, the next thing which you need to know about a concave mirror is it forms real images. Mostly, it forms real images on the left hand side. If I draw a concave mirror, the images are going to be formed on left hand side, on this side. Got my point? So it moves on left hand side, or I can say that it forms in front of the mirror. Simple, no? Concave mirror, the images are formed in front of the mirror. Simple. Please make a note of it. In front of the mirror, as simple as that. Now, the specialty of a concave mirror is concave mirror also forms virtual images. Got my point? Concave mirror also forms virtual images, and these virtual images are obviously formed behind the mirror or in the RHS. Make a note. So, virtual images are formed in the RHS behind the mirror for a concave mirror. Got my point? Please make a note. And one more special thing about the virtual image, formed by a concave mirror is pretty simple. Like many of the students don't know this because they get confused in the numericals. I have seen them, as I told you that 500 students are studying under me, so learning under me. So basically, a virtual image formed by a concave mirror is always magnified. Got my point? That a concave mirror always forms a magnified image in the case of a virtual image. That means if my object is of a height of 2 meters or 2 centimeters, my image, the virtual image formed by a concave mirror, will never be less than the 2 centimeter. It will always be greater than 2 centimeter. Make it. And this question has also come in one of the CBSE 10th board examinations as a board question, that find the characteristics, find the difference in nature of a virtual image of a concave mirror. So students didn't know this, but the difference here is pretty simple, that the virtual image formed by a concave mirror is always magnified. So that's the difference of virtual image formed by a concave mirror with respect to all the other kinds of mirrors. Okay? So I hope all of you guys have made a note of that. I'm going to repeat this again. A concave mirror almost always forms real images, and the real images are formed in front of the mirror or in the LHS. And the second thing, what concave mirror speciality is, it can also make virtual images, and the virtual images formed by concave mirror are formed behind the mirror, that is the RHS, and the virtual images formed by the concave mirrors are always magnified. Okay? So please make a note of it. Even if you don't know what is a concave mirror, what is a convex mirror, even if you don't know what are real images and virtual images, please kindly note this down, because today's topic is numericals. Let us sort this thing out completely. Let us solve the problem of numericals completely. Okay? So concave mirror concept is done. I am hoping that all of you guys made a note of it and you have understood. Keep this thing in your mind very crisp and clear. Moving to the next part, that is nothing else but the convex mirror part. So when we talk about a convex mirror is exactly the opposite of a concave mirror. So I hope all of you guys remember the other name of a concave mirror. What was it, guys? The other name of a concave mirror? Exactly correct. Correct? Super. Concave mirror, other name was converging mirror. Super. Similarly, convex mirror is called as a diverging mirror. Now, if you don't know why they are called as converging or diverging, it's pretty simple. Let me tell you that at least. Concave mirrors, when the light falls on it, they converge the light. They start converging the light. And when you have convex mirrors start diverging the light out. Let me show you that. I think that would be better. Let me show you that. Oh, great. I have a simulation also for all of you today. Super. So let's try to solve this part up. Okay. Let me just magnify it a bit. Okay. I hope that all of you can see the thing. Super. Great. Yeah. Awesome. Okay. I hope all of you guys can see it. Now, this is a concave mirror. Now, we are studying concave mirror to be the other way, okay? The concave mirror is on the other way. If I show you again, concave mirror is supposed to form this way. But here in the animation it's going the other way, so don't get confused. The only thing which you need to know, I'll tell you that. Okay. Now, as I told you that a concave mirror always converges the light. See, this is your object kept in front of you. If I draw an incident ray, if I draw a ray, as you can see, after reflection, it is getting converged. It is getting converged inside. Let me show you one more ray. You can see one more ray. As you can see, after reflection, it is getting converged. One more ray, if I show you the central ray, oh my god, look at that. So all the three rays after, reflection are getting converged inside the mirror. Correct. So that's the reason why converging mirrors are concave mirrors. Similarly, if I show you for a convex mirror, let me show you that. Okay. Let me keep the mirror here. Let me bring the object on this side. So ultimately it becomes a convex mirror. A convex mirror is a mirror whose reflecting surface is bulged outwards. Pretty simple. For concave, it was curved inward. Convex is bulged outwards. Simple and clear thing. Okay. Now, for a convex mirror, if I draw a ray, as you can see, the light ray goes and falls on the mirror and they do not come inside the mirror, or they do not go towards the principal axis, but they go diverged out. Let me show you one more. Look at this. They go diverged outward. Let me show you one more. Look at that. They hit on the mirror and they get diverged out. They do not converge together. So that's why we call a convex mirror a diverging mirror. I hope all of you guys got this simple concept. So let's move on. Let's try to understand what is we are going to study about a convex mirror. Now, as we studied for a concave mirror, that concave mirror can form two kinds of images, real and virtual. We don't have that problem for a convex mirror at all. Convex mirror is the most simple kind of a mirror. A convex mirror always forms a virtual image. As simple as that. So simple. Convex mirror always forms a virtual image and it stays the same position also. Because you have studied that virtual images for a concave mirror are formed on the right hand side behind the mirror. Same thing happens for your convex mirror also. It is formed on the right hand side. So that means if I have a convex mirror here, the image will be formed on the right hand side here. Okay? So that means behind the mirror is your image going to be formed. Please make a note of that, guys. Great. So that's the part which has been done. And now as I told you that virtual image for a concave mirror is always magnified and that is a different kind of a setup. So same thing happens for a convex mirror. The convex mirror forms a virtual image which is always diminished. It's not magnified, it is always diminished. Exactly correct, guys. Super. What I mean to say here is, if I have an object of 2 centimeters, the image formed by the convex mirror will never be greater or bigger than the object. It will always be smaller than the object. Somewhere till 1.9 centimeter also we will agree. Okay? But will never be equal also. It will never be greater also. It's always going to be smaller than the object size. Great, guys. I hope all of you guys have made a note of the convex mirror also. Great. Now let me show you guys the images again. Okay, let me show you guys the images again so that you guys are pretty clear about the ray diagrams. Look this. Look here very carefully. These are 6 ray diagrams of the concave mirror which I have already told you. Look very carefully. Here is a real image formed on the LHS, front of the mirror. Here is one more real image formed on the LHS, in front of the mirror. One more LHS, one more LHS. You can see this is your object and this is your image. Dotted line ones are your image. Look at that very carefully. If you don't know it, don't worry about it. What I mean to say is that LHS is what you will get. Okay. Now, the next thing which you need to know very carefully, adding up to concave mirror and convex mirror is, the final few points are this. Real images which are formed by a concave mirror are always inverted in nature. They are always inverted. What I mean to say is, if I keep the object like this, the image will be formed like that. Inverted. Exactly inverted. Got my point? Exactly inverted. And the virtual images formed by the concave mirror will always be erect. What I mean to say by this, what do you mean by erect? Simple. If I keep the object like this, after reflection when the image is formed, the image will also be erect. Simple. Like this, like that. Inverted means like this and the image is completely inverted. Got my point? Now, similarly, it follows for the convex mirror also. For a convex mirror, the virtual image form is always erect. This gives us a conclusion that virtual images are always erect and the real images are always inverted. Cool? Got it? The same thing goes on for your lenses also. So that's what I'm trying to tell you, that if you're clear with your ray diagrams of your mirrors, then your lenses will be super cool. Okay? So ray diagrams done. That is your first best practice, guys. The first best practice here, as I already told you, you need to know at least this about ray diagrams. At least this much. Okay? About a concave mirror and a convex mirror, at least this much you need to know. Next best practice which I need to tell you guys is pretty simple. That is nothing else but the sign convention, which I need to tell you, which is very, very important. So I want all of you guys to concentrate here very carefully. Before going on to the sign convention, there are few parameters which you need to be super clear about. Okay? So let's take a concave mirror and try to understand those parameters. So here you can see a concave mirror. This is a concave mirror at its best. This is how good a concave mirror looks like. Okay, so here is a concave mirror. Simple. What we have done is, we have kept an object in front of the concave mirror. Okay, and there is one important thing which you need to know here, is that the concave mirror and the convex mirror has a center, correct? And what is the center called, guys? People who know about it? Exactly correct. Superb, superb, exactly correct, amazing. The center of concave mirror and the convex mirror both is called as a pole. Okay? And is denoted as P. It is denoted as P, as simple as that. Cool? Now, from the pole to the place where the object is kept is called as object distance U. What a point? U is equal to object distance. Simple. That is the distance between the center of the mirror to the place where the object is kept is called as U equal to object distance. Got my point? Now, after reflection and all those stuff, we'll get an image. We will get an image. Correct. And as you can see here, can you guess whether it is a real image or an inverted image? Or it's a real image or it's a virtual image? Can you guys get it? Exactly correct. It's a real image. You can say clearly because you are seeing an inverted image. The arrow was set like this, but you're seeing an image like that. So it is an inverted image and you are pretty much sure about it right now that all the inverted images are real as of now. Okay? So you guys can note this down as it's a real and inverted image. Cool? Now, from the center of the mirror, that is the pole, to the image, the distance between the pole and the image is called as V, or nothing else but the image distance. Simple. It's called as the image distance. That's all, guys. That's it. Okay. Now, there is one more very, very important point which you need to know. That is the point of focus. Correct? That is the point of focus. Now, many of you guys might not know focus. Oh, I can see many of you know it. No, people who don't know it's pretty simple. If you have any kind of a mirror, let's take a concave mirror, the light rays will fall on the mirror and they will get converged. Correct. They get converged at a point, and that point is called as focus. Simple. Cool. I have a mirror, concave mirror especially. All the light rays falling parallel. All the light rays falling parallel onto a concave mirror, after reflection will converge at a point, and that point will be called as a focus. One of the most important points for your numericals. So that focus, the distance between the focus and the pole is called as what, guys? Exactly correct. Super. It's called as focal length. Super. Amazing. Great. Awesome, guys. So you have understood the focus, you have understood the pole. Now the distance between the pole and the focus, as I said, it's called as focal length. It is denoted by a small letter f. So the three major things which you need to know here is u, v and f. You know, correct? There are two more things which you need to know. Finally, it's pretty simple. The height of the object, that is how high the object is given by h. And how height the images, like how much longer or what is the length of your images, is called as h dash. So these are two more things which you need to know very, very clearly, h and h dash, because your entire sign convention depends upon that particular parameters. Okay? So we have studied u, v, f, h and h dash. U being the object distance from the center of the mirror, v being the image distance from the center of the mirror, and then we have f. F is the distance between the focus and the pole. Then you have h, the height of the object. Then you have h dash, the height of the image. Super, simple, very clear. Good job. Now we are going to understand the concept of sign convention. I want everyone's complete attention here. We'll take exactly 5 to 10 minutes to complete the sign convention. Then we are going to solve an amazing numerical. Great. So guys, complete attention here. Now, let me tell you the second best practice for today. The second best practice for today is always remember the sign convention as a graph. Okay? Always remember the sign convention as a graph. How you make a graph? You make a graph with the help of a system called as Cartesian system. Got a point? Always remember this. Always remember this. That sign convention is nothing but a Cartesian system with the help of which you make a graph. What do I mean by Cartesian system? Simple. Positive y-axis, negative y-axis, positive x-axis, negative x-axis. That's it. That's what I mean by Cartesian system. It's like just like a normal graph. Cool? So let's try to understand what is sign convention. Let me tell you why do we use sign convention. It's pretty simple, guys. Imagine I give you a scenario where I give you a mirror and I give you the object position. Okay? And the image is formed. You are drawing the image perfectly well and you're super good at that. I'll give you now a similar kind of a numerical to do it. You'll get the value. I'll ask you object distance is this much, focal length is this much, and this is your mirror. Find the image distance. You will find the image distance. Correct? Exactly correct. Superb. But there is going to be a problem. The problem is your concave mirror can make image on the left hand side also and on the right hand side also. And the convex mirror always makes the image on the right hand side. So when you are doing the numerical and you get, imagine for a value 20 centimeter, how will I know that 20 centimeter is in front of the mirror or behind the mirror? How will you know? We don't have any way to know that, right? Imagine you have not drawn the diagram also. Well, how will you know that? There comes your sign convention. There comes. So with the help of the sign convention, by just looking at the value of the property or of the parameter u, v, f or whatever it is, you will be able to understand at what position the object is, where is the object and how big the object is. Entire thing you will be able to understand. Got a point? So that is where we use our sign convention. So let me tell you how it is used in a numerical and how important it is. So as I told you, let's understand sign convention. So first of all, let's make a graph. I want everyone to make it with me. Make it with me so that you understand the sign convention at least pretty clearly. Okay. So let's make a graph first. Let me make, what to say. I'll make the y-axis. Oh my god. You guys know that I have amazing drawings. I have amazing drawing skills, right? Okay. Yeah. You can see it, right? Yep. Can anyone make such a straight line? No, right? One second, guys. Okay. Oh my god. I'm so bad at this. I think I should delete it and draw it again. 1 second. Okay. Yeah, finally got it. Oh no. Okay. Why am I so bad at this? Yes. Got it, guys. Finally got it, guys. Yes, that's your y-axis here. Okay. So so y-axis is positive on top. You guys know that, right? Yeah. So it's your positive y-axis and this is your negative y-axis. Correct? Superbly amazing. So similarly, let's make x-axis also. So here is your x-axis. Cool. So this becomes your positive x-axis. Correct? Positive x, and this becomes your negative x. Super. Cool. Amazing. Done. Good. Awesome. So now what you need to do here is make a mirror. Keep it at the center of the graph. Cool. So let's make a concave mirror now. Let me make a concave mirror, and as I told you, your concave mirror should be at the center of the graph. And one more very important thing, the center of the mirror, that is your pole. The center of your mirror, that is your pole, must be coinciding with your origin of the graph. Got a point? That means origin and the pole must be at the same position, and then you make your concave mirror. This is how it should happen. This is the perfect way to happen. So in that scenario, your x-axis will become the principal axis of your mirror. Now what is this principal axis? The principal axis is nothing but an imaginary axis which passes through the center of a mirror. Got a point? It's an imaginary axis that passes through the center of the mirror, and let me call this as the focus of the mirror. Both. Okay? So it's an imaginary axis that passes through the focus and the pole of the mirror. So till now you understood? Super cool? Okay, great. Now what you need to do here is very clearly draw or take your object. So I am going to keep my object on the left hand side. And this is the behind the mirror. Okay, so I am gonna mark it like this. So that is behind the mirror and this is in front of the mirror. Now obviously we cannot keep an object behind the mirror. So that would be really foolish and stupid, correct? So let's not keep the object behind the mirror. For a mirror, the object is always kept on the LHS. This is your LHS. Always kept on the LHS. This is your RHS. Got my point? So guys, so what is the distance between the pole and the object called? Super. It's called as the object distance. Amazing. Amazing. Correct. Now think and tell me, according to the graph, if I get that the object is kept at some position here, U, that U value must be positive or negative. What would be your answer? Amazing, guys. Amazing. Your answer must be that the value should be, sir, it must be negative because it's falling on the negative x-axis side. Correct. So yes. So as you can see very clearly right now, that U for a concave mirror must be a negative value. Now it's not only for a concave mirror, guys. For a convex mirror, for a concave lens, for a convex lens, and of course for the concave mirror. For each and every mirrors and lenses in your syllabus, the object is always kept on the left hand side, even for the lenses. So your U is going to be always and always negative. Got a point? Super. One more thing. Let's talk about the focus and the focal length. Now you have F, right? You know what is focal length? Focal length is the distance between the pole and the focus. So this is going to be your F. So I am going to write down my focal length here, F. What should the focal length be? Focal length should also be negative, obviously, because it's falling on the left hand side. Simple, crystal clear, not at all. Now let's talk about the complicated stuff. Let's talk about V. Let's talk about V. What is happening to your V here? Now, as you guys know, that a concave mirror can make a real image as well as a virtual image. Correct? So, concave mirror makes a real image on which side? Left hand side or right hand side? In front of the mirror, behind the mirror, guys? I hope you remember I asked you to note it down. That was the first best practice. Super, guys. Amazing. Exactly correct. It forms in front of the mirror. I can see some amazing students here. Great job, guys. I'm really proud of all of you. So yeah. So whenever it makes a real image, and you know that real images are always inverted, the real image is going to give me an image distance of V. And for all the real images, I am going to get a negative value for V. Okay. Image distance is going to be always negative because it's falling on the left hand side or in front of the mirror. Similarly, if I ask you, what is it going to be for virtual image? Guys, it's going to be negative or positive? Super, exactly. As of you guys know, all of you know that virtual images are formed on the right hand side erect. Correct. So it's going to be a positive value when we talk about image distance for virtual images. Correct. So U is negative, F is negative, V can be negative and positive both. Negative for real, positive for virtual. So that's done. Now let's talk about the other two parameters which we learned right now. One is H. Correct. What is H? H is the height of the object. As you can see, height of the object is always standing straight, right? So it's always the positive y-axis. So height of the image is always positive. No negative problem at all. But when you talk about height of the image H dash, height of the image is a complicated stuff, same to same as of the image distance. Same to same as of the image distance is complicated stuff, because for real, it's inverted. For real images, it's inverted. So you can see that the height of the image is going downward. Negative y-axis. So for all the real images, H dash is negative. Similarly, you can see for all the virtual images, it's going upward. So it's the positive y-axis. So H dash is positive or virtual. It is positive. Simple scenario. Got it, guys? So right now we have understood 5 major sign convention for a concave mirror. That's it. That's it for a sign convention. Now why you need to remember this? I'll tell you that when we are doing the numericals. This is one of the very important stuff. You need to know this completely well. Got a point? So that's it, guys. I hope you guys remembered it. You guys have made a note of that. Now if I ask you similarly for a convex mirror, I will not solve. You need to help me out to solve that. Okay, I'll tell you the points. You tell me what is the answer. So we'll do the same thing, guys. I want all of you guys to make the graph again, and this time at least let me make it proper. Oh my god. Oh, red is my favorite color. So it's how fast it is done. Awesome. Red is awesome. Okay, let me just write that down. So this is your y-axis positive, and this is your y-axis negative again, and this is your x-axis positive, and this is your x-axis being negative value. Correct. So now we are going to make a convex mirror. So let me make a convex mirror here very clearly. Oh my god, my drawing skills. Okay. Yes, made it. Nailed it, guys. Awesome. So P here and O here. Awesomely well. Okay. And this is the back part of the mirror, behind the mirror. So let me just mark that down separately. Okay. Now, as I already told you, the object should always be kept on the left hand side. So guys, quickly tell me, U for a convex mirror, what should it be? Exactly correct. Superb. U must always be negative. Correct. Superb. Now, let's talk about V. Before going into F, let's talk about V. Where do the convex mirror make an image? LHS or RHS? In front of the mirror, behind the mirror? Exactly correct. They make images behind the mirror because it's always a virtual image. And you know that the virtual image is always an erect image. So yes, V is going to be always, like always, positive for your convex mirror. Take that down. Take that down that the image distance for a convex mirror is always going to be positive. The object distance for our convex mirror is always going to be negative. And let's talk about the focal length right now. Focal length for a convex mirror is not on the left hand side, it is on the right hand side. Okay? I will not tell you why it is on the right hand side, that is for a different webinar, but please take a note of it. Focal length for a concave mirror is on the left hand side, but for a convex mirror is on the right hand side. Okay? Please make a note of that. So focal length, obviously here is going to be positive. And then we go on for H. H should be positive because standing straight. And obviously H dash also should be positive always because your image formed here is a virtual image. Correct. So as you can see, each and every one of them are always like permanent thing for a convex mirror. Correct, guys? Superbly amazing. Amazing, right? Exactly. So with that, you have completed the sign convention problem of your light chart. Take it completely for a concave mirror, for a convex mirror, both. I believe that you guys have made a note of it. If you have done it, then we can go on to apply our formulas of reflection and directly jump onto a numerical. Shall we do that? Yeah? Okay. Awesome, guys. So let's start doing it. So first things first, let's talk about the formula. Now in your mirror part, there are only 3 formulas. Three major formulas. Let me explain you that formulas first very clearly. Number one, the first formula which you will learn in the chapter, if you have not learned it yet, if you have already learned, the first formula is going to be your radius of curvature is equal to twice of the focal length. Okay, twice of the focal length. What do I mean by that is, if you have a mirror, if this is a concave mirror, this mirror, even for concave or for convex, they are actually a part of a bigger circle, correct? Or let me call that in 3D a bigger sphere, correct? So if I complete this concave mirror here, I should get a complete sphere, correct? Complete sphere. This feature denoted as point C, or a point denoted as C. And obviously this mirror will have the center of itself, that is the pole. You know that. The distance between the center of curvature and the pole. How many of you guys know the mirror formula? Quickly tell me. You know it? Awesome. Many of you don't know it? Really? Simple thing, no? Got it right? Okay. So what is the mirror formula? Mirror formula is pretty simple. Mirror formula is 1 by f. 1 by focal length is equal to 1 by image distance plus 1 by object distance. Correct. That is your mirror formula right there. With this, you will be able to find out the focal length of a mirror, or the image distance, where is it from, or the object distance, where is it from, with the help of that formula. Cool, awesome, correct, amazing. Now let's talk about the magnification. Now magnification. What is this magnification and why is it important? With the help of the magnification, listen to me guys completely, pay attention. With the help of the magnification, you will be able to know whether the image form is magnified or diminished. Simple. Okay. You will compare it with the object, and magnification will give you what is the size of the image. Is it magnified or is it diminished? That's what is the magnification going to give you. And the formula for m will be equal to minus v by u, where v is the image distance, u is the object distance, and m is the magnification with a negative sign there. Got it? So this is your third formula. But magnification value does not only give you magnification, it also gives you the nature of the image also. I'll tell you how. I'll tell you how or what is nature of the image means it will give you whether the image is real or inverted. With just one image, magnification value, you will be able to know all this stuff. So it's a very important formula. I ask you to note it down. I also tell you how it is going to tell us. Okay. Now nature of the image, correct? Nature of the image is there. And there is one more formula for magnification which you need to know very clearly. It is h dash by h. Height of the image by height of the object. H dash, you know, height of the image divided by the height of the object. Simple. Now, what is the importance of magnification? Let me tell you that. Okay, it's a very crucial thing, and this is the third best practice, that you need to know the importance, or that you need to know what are all the formulas going to give you specifically. What are they going to give you? So the third best practice would be understanding the formula itself. Understand your formula. Understanding your formula. Very, very important. What is the significance of all those formulas? It's very important. Okay? So listen to very carefully. The most important thing about magnification is, if the magnification is negative, that would mean it's a real image. It's a real image. I'm telling you, we can prove it out. That's a different scenario. But magnification is negative, it's a real image. Number two, if magnification comes out to be a positive value, it is a virtual image. Note it down right now. These are the tips which you need to know about while doing numericals. Okay? If magnification is negative, it's a real image. If magnification is positive, it's a virtual image. Got a point? Next things next. If magnification is less than 1, that means it's a diminished image. Correct? It's not bigger, it's diminished. Cool? If m is equal to 1, that would mean that the height of the object and the height of the image are same. They both are of same size. Number 3, When magnification is greater than 1, that would mean that it's a magnified image. Let me prove it to you how it is diminished, how is it same size, how is it magnified. So the height of the image is lesser than the height of the object, that meaning it is diminished. Correct? Simple. And also if I tell you m is greater than 1, that means h dash by h is greater than 1. So h dash is greater than h, giving you a value of height of the image greater than the height of the object, giving you a magnified image. Correct? So this is how we can prove it out. Now let me ask all of you a very simple thing. Now a lot of students go wrong in this. A lot of students go wrong in this. So let me ask you guys a very simple question. If you get m is equal to minus 2. M is equal to minus 2. Okay? Simple. Tell me this. Is it a magnified image or is it a diminished image, guys? What do you think? Is it a magnified image or is it a diminished image? What do you guys think? Oh, I can see a lot of students telling me diminished. Also telling me magnified. Yeah, great. Interesting. Good job. Awesome. I can see a lot of you guys telling me it's diminished image, but also a few of you guys telling me magnified. Guys, you must understand one thing, that do not consider this negative sign to say that minus 2, sir, is less than 1. So it is a diminished image. No. This is the doubt which a lot of students has. This negative sign only and only indicates whether it is real or virtual. This is the value which you must look forward to. Okay? So when I say that it is less than 1, I mean 0 to 1. Less than 1 means 0 to 1. I do not mean in any other way. I do not mean the negative integer part at all. Cool. So now tell me it is a magnified image or diminished image? 2 is greater than 1. So it's a magnified image. Super guys. Now you understood that? Pretty clear? So all of you please make a note of this entire concept of magnification. Very, very important concept. Then we'll proceed on to our first numerical today. Okay? And this numerical, let me tell you, it's a very, very important numerical from your NCERT textbook. Also a very, very important numerical in terms of your CBSE 10th board examination. It has come plenty of times. Similar kind of questions have come plenty of times. It has come for my own board examination. So it's really important to know this. Take care. So please guys, I hope all of you guys have understood from the starting the 3 major best practices I have told you till now. In the numerical, I tell you 2 more best practices. So everyone look very carefully. Take care. Now, I will tell you in the numerical itself how to solve it or how to answer the right option without even solving the question, by just doing it in your mind. If you remember all these 3 best practices, you don't even have to do it at all. You can give the answer by just calculating in the mind. Let me tell you how. Okay? Anyways, right now it's completely on you. You do it by hand or do it in your mind and just tell me what would be the right answer for this question. And this is a level 5 question. What I mean to say is one of the most difficult questions which have come in CBSE 10th. One of the most difficult questions. Okay? मतलब सबसे इसके ऊपर कुछ नहीं आएगा. It's like that. Don't worry. Still, and just think about it and do it. And I'll tell you how easy it is to answer this. Okay? Go forward. I'll give you exactly 1 minute to tell me whether you are able to do it mentally and give you the right option. Try to solve it. Simple question. Oh, already you guys are pinging me. Okay, that's great. So an object of size 7 centimeter is placed at 27 centimeter in front of a concave mirror of focal length 18 centimeter. At what distance from the mirror should be a screen placed so that a sharp focused image can be obtained? Find the size and nature of the image. Correct? So they are basically asking you what is V, that is the focused image obtained. Kahan pe mil raha hai? So they are asking you the image distance. They are asking you the size of the image, that is nothing but h dash is the size of the image, and then they are asking you nature of the image, that is basically real or virtual, which you will understand with the help of magnification. Correct? Simple thing. So I have given you the options only for h dash, because if your h dash is correct, every other answer will be correct. Obviously it will be correct, because h dash is what you find at the end. Simple. So go forward with it guys, apply the mirror formula, apply the other formulas of magnification, try to tell me what is the right answer. Go forward. Exactly 1 minute I'm giving you. So guys, awesome. You guys are already doing it. Great. Meanwhile, were you guys enjoying the session till now? Till now, crystal clear about the ray diagrams? Very properly clear about the sign convention because we took a lot of time to understand that. Yeah? Awesome guys, awesome. That's super cool. Super cool guys. Now we are talking about numericals. Let's see what is going to happen with the numericals. As I told you, within 15 minutes, you will be capable of doing a numerical. Here is a numerical exactly at 15 minutes. You will be capable of doing that. Okay? So don't worry about it. Chill. Take care. Don't worry. Let's see what happens. How many of you guys give me the correct answer? Great guys, great. Awesome. I can see a lot of students giving me the correct answers. Interesting. Okay. Then. Final 10 seconds. Final 10 seconds. Please choose your options. Oh, there are a lot of A's and a lot of B's and a lot of C's and D's. Everything is there. Awesome. Great. Okay. I'm gonna end the time right now in 3, 2, and 1. Now let me tell you how to solve this. Without even doing. My pens are down. I want everyone to look over it. Very carefully. Listen to me. Listen to me. Just listen to me. Very carefully. The only thing they're asking you, first of all, is at what distance from the mirror should a screen be placed? So that a sharp focused image can be obtained. So they need to obtain an image on a screen. And people who know this, virtual images can never be obtained on a screen. Only real images can be obtained on a screen. Got a point? So they are telling at what position will this image be formed so that it is formed on the screen at very sharp. So it's clear that it's a real image. That's our first hint for the question. It is a real image. So you know, real images are always inverted. Correct. So real images are always inverted. You guys know that. So for all the real and inverted images, guys, what is the h dash value? Is it positive or is it negative? For all the real and inverted images, exactly correct, is always negative. Correct? Here there are two options giving me A, which is positive, so cancelled out. B, positive, so cancelled out. Simple. Till now to understood. No. Now the problem comes in. Now they say C is minus 14 centimeter and D is minus 7 centimeter. So now it becomes problem. Now you don't know what to do next. Correct. So negative sign has come up. Now the problem is that they say, now let me tell you how to do it without solving it. Now let me tell you the scenario. Let me tell you the scenario of this. Let me draw a diagram first. I want all of you guys to make a diagram for this with me. It's a concave mirror, so I'll make a concave mirror with me. I will write down my pole as here, focus as here, center of curvature here. They say that the object is size of 7 centimeter is placed as 27 centimeter in front of a concave mirror. So they are kept and focal length is 18. So this length here is 18 and the object is somewhere 27. Before going to the object, guys, tell me quickly, where should be the center of curvature? Center of curvature must be what value? Exactly, it should be 36 centimeter because you know double of focus. Correct. So 18, 36. So that means your object is somewhere between here. Your object is somewhere between center of curvature and the focus. And the best part about ray diagrams, the first best practice which I told you, let me show it to you. Okay. So here if you have, if you know the ray diagrams super clearly, you will not be facing any difficulty. Let me show that to you. Whenever, one second, let me just clear this up. Okay, where is the object? Yes. Whenever the object, the focal length was 18 centimeter, right? The focal length was 18. Let me give it as 5. And if 5 is the focal length here, the center of curvature will be at 10th position. So let me keep the object somewhere between 5 and 10. Like just to explain it to you. Whenever the object for a concave mirror is between focus and center of curvature, if you know the ray diagram, you know it very clearly, the image will be formed beyond center of curvature. real and inverted, but beyond center of curvature it will be formed. Cool. And it will always be a magnified image. So that's why I told you ray diagrams are pretty important to know. Cool. So whenever the object is between center of curvature at 10 and between focus 5, the image is going to be real and inverted and it's always going to be magnified. So that tells us, without even solving the question, if you know the ray diagram super clearly, that the height of the image must be greater than the height of the object, which is 7 centimeters. So that cancels out this options also, and what you're left with option C, complete. Got a point? So without even solving it, if you know the previous best practices, you can actually give the right answer. Now you might be thinking, sir, there are no options given in the examination. How will you find it out? Don't worry guys, even if the options are not given, you know what will come. You know that x dash must be a negative value. You know that the x dash value should be greater than the object distance. It should be a magnified image and it should be a real image. So m value should also be negative. M value should be greater than 1. So you know all this already. And this becomes the fourth best practice. That is to verify your answers while you are doing the question itself. So when you will be doing the question or before the question, as soon as you read it, all the answers are already there in your mind. The only thing is one numerical value should be there in front of it. Simple. Got a point? So that's how, like a boss, you should do this, attempt this problem. Now mathematically too, you can do it very clearly, correct? We'll do one more problem. But right now, it is time to, tell you guys a very important thing. So exactly, correct answer is minus 14, as I told you that already. Now the important thing here is, I hope that all of you guys understood the right approach towards the numerical way. I know we didn't solve a lot of numericals, but this session was not about only numericals, it about the best practices. And I believe all of you have understood those best practices. Number 1 is to always remember the ray diagrams. Number 2, to understand where are the images formed. Even if you don't know what is the ray diagram, even if you don't know the ray diagrams, to understand for a concave mirror, what are object distance, image distance, this is this. For a convex mirror, what are this. Number 3, we went in super detail as I promised into sign convention and we cleared that up at all. Correct. Now in the similar way, I want all of you guys to remember this link also. Please note down this link. It's vdnt.in/numerical CBSE 10th or NUM CBSE 10 or X. Okay? NUM CBSE X. Now once you go into this link, you will be landing here on this particular page where Vedantu has come up with an amazing course dedicatedly on the physics numericals for CBSE 10. Got a point? So here we'll not be dealing with a lot of concepts theoretically, but we'll be focused on numericals alone. Got a point? So concepts related to the numericals will do, but apart from that we'll not do. Right? All the things, as you know, as you understood right now, the numericals we were able to do right now because we understood the concepts related to the numericals. So in that detail we'll be going into very much clearly, so that at the end of the course you guys top or ace the board examinations in terms of numericals complete. Cool? So what are the benefits of this course would be, I would just say what are we going to cover in this course. All the numericals of spherical mirrors, all the numericals of refractive indexes, lenses, and the numericals of power circuits, resistance circuits, and Ohm's law, electric current, potential difference, heating effect. Then we'll jump on to the major concepts of magnetic effects. I know magnetic effects does not contain in numericals, but major concepts of magnetic effects like working of a DC motor and an AC generator, all those terms will be going in pretty much deep with their respective concepts pulled in. Okay? And the best part about this courses would be that all the recordings, all the videos which will be happening with me, the session which is going to be happen with me, all of them will be recorded. So you can watch the recordings whenever you want, even after the course is ended. And 24/7 we will be connected through a WhatsApp group. So whenever you guys have a doubt, you can contact me through WhatsApp group. And also after the course is ended, the WhatsApp group is still going to be there. You can still contact me for any other chapters. Okay? and the handwritten notes by teachers and other notes and tests are going to be conducted for all the chapters. It will be there. Okay, so you guys at the end will ace it. Now basically, as you can see, the lightning deal is going on right now for all the chapters of numericals. It's for 3,000 rupees, 3,000 rupees course with the lightning deals for 1,500 rupees. So yeah, so this is the page which you guys are going to be in after you click on that link. Okay. So right now guys, I hope all of you guys understood this part. Let us do one more numerical. Before that, I'll request all of you guys to note down this link again. Now let us do a numerical straightforward properly. Okay, so that you guys say, sir, you didn't do a numerical at all. So let's do a numerical very clearly. Let's go back to the numerical which we were discussing in the starting itself. The numerical which I showed it to you. Correct. So I will give you exactly 1 minute to solve this one. Okay. So go forward with it. An object, as I told you before reading the question, this is a 12th standard board question. It's important. Go for it. An object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, by how much distance is the image displaced? What is the answer for this? Go for it. 36 cm, 24 cm, 12 cm, 45 cm. Now we will do this problem straightforward, very clearly. Yeah. Any answers already? Already many people are putting the options. I believe you guys are my students only. I know that. Just kidding. Okay. Awesome. I think I should have some water. Great guys. Super cool. Okay. Still doing? Okay. Waiting. 20 more seconds left. Just 20 more seconds. Do it quick. Do it quick. Oh my god. Already 1 hour passed. That's interesting. Come on guys. Quickly, quickly, quickly. 10 more seconds. Option chosen. Oh yes. A lot of people choosing, going for A, then B also, and C also, D also you're going. Achha, all the options selected. Okay, awesome, awesome. In 5, 4, 3, 2, and 1. Your time is done right now. Super, super done. Okay. Now listen to it very clearly. Let's try to understand what is being asked first. Okay. Let's try to draw the diagram and solve this diagrammatically first. Okay. So I hope that you guys are super, ready to do this because it's a very important question. Let us just do it with diagram. Okay. 1 second. Cool. So yeah. So an object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. Okay. So let's just draw a diagram here straightforward. Let me take a new page and let's draw a diagram. So you have a concave mirror here and let's see what is the focal length. Placed at a distance of 40 cm. So you have an object U at a distance of 40 cm U. Okay. And it has a focal length of how much? Somewhere about 15 cm. Okay, so the distance focal length is 15 cm. Super. And then you can see if the object is displaced through a distance of 20 cm. So now they are trying to tell you that you had the object at 40 cm. Now the object has displaced to 20 cm towards the mirror. So that means the object went this way. 40 से 20 में चला गया. तो नया distance क्या हो गया? नया distance हो गया 20. Correct? Simple. But the focal length of the mirror will remain the same. It is not going to change. It's going to be 15 cm only. Now they are asking you, what is the change in the image? What is the displacement in the image? Image might have been here for this and here for this. What is this displacement between both these images? That's what they are asking you. Very simple. So that's, super simple to do. Correct? You just need to find out what is the image distance V for this and what is the image distance V for this. That's what you're going to do. Let's try to apply the formula, which is nothing but mirror formula here. So we will have 1 by F is equal to 1 by V plus 1 by U. Cool. Now 1 by V is what we need. So we will get 1 by F minus 1 by U. Correct. So let me just rub this off. And then 1 by V will be equal to 1 by F is what here? F is 15. We should take it as minus 15 because it's a concave mirror, left hand side. So minus 15 centimeter. Then you have this negative sign. Let me put that up. 1 by U is there. for concave mirror, u is also negative. So we must take it as minus 40 centimeter. Correct? Let us open the brackets right now. We'll get 1 by minus 15. Minus minus becomes positive 1 by 40 centimeter. So my final 1 by v will be equal to 40 minus 15 divided by minus 15 into 40, which is equal to nothing but 25 divided by minus 15 into 40. So that will be 5 3s are and 5 5s are, 5 1s are and 5 8s are. Correct. So your answer will be 1 by v is equal to minus 1 by 24, which is v equal to minus 24 centimeter, and that's superbly correct because it's a negative value. So I'm not even going to doubt the magnitude of it, because v, when it is real for a concave mirror, you know that it's going to be a negative value. So yes, it's going to be a negative 24 centimeter. 1 second, I'm drawing it at the wrong place. So object is here. Image will be formed somewhere here. This is formed at minus 24 centimeter. That is your V. Now similarly, let's try to do it for this particular situation. Okay, similarly, let's do it for this second situation. So you're saying 1 by V will be equal to 1 by F minus 1 by U. Correct? That's what you learned. And here 1 by F is nothing but how much? 1 by minus 15 remains the same. And then minus 1 by U is nothing but minus 20. Correct? That's what you written. So it will be 1 by minus 15 plus 1 by 20, giving you an answer of 20 minus 15 divided by minus 15 into 20 again, giving you an answer of 5 divided by minus 15. I can see for this also we are going to get a negative value, super clear. 5 1s are, 5 3s are, and V is going to be minus 60 centimeters, amazingly well. So if we go back here, we can find out that the image distance will be somewhat here, giving an answer of minus 60 centimeter. Correct? So you know, initially the object was here. Initially the object was at minus 24. Now the object is at minus 60. What is the displacement? The displacement is of minus 36 centimeter. Correct? No? Minus 60 minus of minus 24 displacement. Initial position minus final position will get minus 36 centimeter. So let's go back to the options. Oh yes, minus 36 is the damn right answer. Great. Many of you guys who gave me option A, well done guys. So as I said, when you know the right concepts, you will be able to solve anything, any question coming out from any board, any standard. Great. That's it guys. That's it from my side. Before ending, I will be giving you guys a homework so that you guys can practice a lot with this, and I want the answers for the homework which I am going to give you to you right now. I want it right down in the comments below. Okay? So try to apply all the best practices. Oh, 1 second. Did I tell you the 5th best practice? Guys, the 5th best practice for this particular concept which you have learned today would be the same concepts, apply it for the lenses. That's it. So that you don't have to remember lenses separately. All the concepts are same for mirrors and lenses. Nothing changes. Sign convention will change here, then, there. That's it. And that also you know how to apply the sign convention. So you are at a good position right now. Great. So right now guys, giving you the homework for today. Yes, that is the homework right there in front of you right now. Okay. So please note down your homework right now. And please let me know what is the correct answer for this question right now in the comments below. Let me see who answers this question first. Okay. And people who want to contact me after this webinar, you can always send me an email at k.abhishek@vedantu.com. Okay. If you have any doubts related to this particular webinar, please let me know at this email ID. Also, you can put that doubt in the comments below with the answers. Okay. I'll be personally checking it out. So that's my email ID, guys. Please make a note of that. Okay. At the end, I will just share the link to you guys again. So yeah, the link is here. Yeah. So please note down this link again. So with that guys, we'll end the session right now. Thank you for bearing with me for 1 complete hour. So with that, bye bye. Take care guys.